Okay, let's take another example to illustrate the distinction. What can we do? There is something I wanted to ask you, because I've been sort of thinking about it for some time. Let me take a piece of paper and ask you. So, suppose I take this piece of paper. I don't want to fold this is an important piece of paper, so I'm not going to do that. And let me take another piece of paper. Okay, here's a piece of paper. So, supposing I fold it like this randomly, anywhere.
Yeah.
Right? So I hope all of you can see this. I'm folding it now, and then I'm going to fold it again this way, such that this is not random. I'm folding it such a way that these two folds, one lies on top of the other, and like that. Right?
Okay.
Now, if you look at this line and this line, you will see that this is a right angle.
Yeah.
Right? Or if you look at it this way, this is the right angle, this is the right angle.
Yeah.
So let me draw that for people to see very clearly. Okay. So this we can erase now. So here's the first fold, and here's the second fold, and let me call this A, B, and this is C, B. You can see that they are both right angles. This is what I feel. This is what I think is true. So this is my. This
you
is
think
my
it will always be true when you fold it however you fold.
That's my conjecture. If you fold it this way, if you follow the instructions,
on any piece of paper
matter
or any other material,
these two will be right angles.
Absolutely right.
You can also call it in science. You will call it a hypothesis. And you're pretty much certain that this hypothesis is true, that this conjecture is true. How will you prove it? Using mathematical inquiry? How will you prove it using scientific inquiry?
The scientific inquiry one is kind of easier.
Yeah. Okay, so let's do that here.
Yeah. So you take a large sample of pieces of paper.
Okay. So, scientific, you begin with the large sample. Okay, then what do?
You actually do the procedure on each of them.
Okay, so let's call it an experiment.
Yeah.
The experiment is folding it the way I described it, and then folding it again, and then what do? You have to measure the
Open it up and then you measure,
Okay. The experiment will include measurement.
Yeah. You get one of those protractors and you measure, and you'll see that it's 90 degrees.
Okay, outcome of the experiment. So there will be many angles, and you measure each.
Yeah.
But when you measure each angle, you're not going to get exactly 90 degrees.
Yeah.
You will get somewhere between, let's say, 89 degrees to 91 degrees.
Yeah.
That will be the range, because you can never be.
Your measuring instrument won't be perfect.
Yeah.
You will make.
And the fold would be slightly.
Yeah.
So approximately this much, and you'll take this. These are the data points, right? And then you take the average. Okay. And you know that it's, like that, 89 to 91, somewhere in that range.
Yeah.
Okay, so you say that's the average angle.
Yeah.
So, but I want to prove it's a right angle, not. But that's not.
What is 90
You
degrees?
can prove it is 90 degrees.
Okay. What is the right angle?
Okay, you could say, actually, you can say definition of a right angle is this.
Is 90 degrees.
Right angle. Oops. Right angle is 90 degrees. So what you proved is it's approximately a right angle given this definition.
Yeah.
That's fair enough. Yeah. So that's a scientific proof.
Yeah. And what you do now, so you've probably done this only with paper.
Yeah.
You can try with other materials also.
Yeah, but my hypothesis is about paper.
It's just about paper. Okay.
Yeah.
Okay.
So I'm happy with this proof.
Okay.
So you have argued and you have shown that if you follow that procedure, you will get approximately 90 degrees, and we are defining right angle as 90 degrees.
Yeah.
Okay.
But notice you've done this only on Earth, you've only done it with a small number of paper and so on. Maybe if you got Mars and you take paper from Mars,
it may not.
work.
That's right. Or if you take a very large piece of paper, it
Yeah,
might be.
maybe it'll be different. Yeah.
Yeah.
Like 10 kilometers by 10 kilometers, maybe it'll be different.
So what I've shown is that until I come across some counterexample,
Yeah.
then it's
We
reasonable to believe that this is so.
Yeah.
Again, it lacks total certainty.
Yeah.
Okay. Now how do you do this as a scientific proof?
As a
this
you
will be
mean
a right
mathematical.
answer? Sorry, as a mathematical proof.
Yeah.
Yeah.
So now that comes to this again. We have to define right angle.
Yeah, 90 degrees.
See, 90 degrees is a useful way of measuring.
Yeah.
Because protractors are 180 degrees, so 90 degrees is a useful way of measuring.
We can do that in mathematics. Yeah. 90. That's what textbooks say.
Textbooks say that, but the problem with that is that, so for example, if Napoleon had won in a war,
Right.
he wanted the entire thing, the entire circle to be 100 degrees. So right angle.
What do you mean circle is?
Oh, so the measure of the angle of the entire circle, the sum of all these angles should be 100 degrees. So I mean the right angle would be 25 degrees.
Wait, okay, what you mean to say is, if I take a line like this, and if I rotate,
Yeah,
and you come down back here, then you have rotated
100 degrees.
100 degrees.
But currently we use 360.
Ah, I see.
But if Napoleon
A
had
full rotation is
360.
100 degrees versus 360 degrees.
So the number of 360, 90, 100 are all just arbitrary. They're
Yeah.
just decisions people have made. But they're not what the actual thing is.
Ah.
Right?
Oh, actually, now that you mention it, there is something else. I remember I learnt in school that in Euclid, a line has no breadth, there is zero breadth. If a line has no breadth, this is not strictly speaking a line because this has breadth.
So you can't measure a line. You can measure this.
I can measure this because I can see it.
Yeah.
But anything with zero breadth,
How do you
how can you see it?
Yeah.
So you cannot measure it.
Yeah. You.
Okay. So the definition of right angle as 90 degrees is okay for science, but not okay for
No.
mathematics.
Yeah. Because there's no
How do you
protractors in mathematics.
Yeah. How will you define it then?
So let's try this. If you have a straight line and a line,
Another straight line.
another straight line comes here, and these two angles are equal to each other,
Right.
then you say it's a right angle.
Okay. Let me write that down to make sure I understand. The definition of right angle you're proposing is if line A stands on line B, actually instead of saying line A, supposing I said line AB stands on line CD,
A, B,
yeah,
C,
CD, and if this angle,
A, B, C,
angle ABC is equal to angle this
A,
angle,
B, D.
ABD, they are congruent.
Yeah, they're congruent. Then both ABC and ABD are right angles.
Then yeah, ABC and ABD are right angles. That's very interesting because this definition and that definition are quite different. Okay, all right. So that's the definition in science. This is the definition in math.
Yeah.
Okay.
So now notice when you did the procedure, what happened? What were you doing? Let's get the piece of
The piece of paper where they keep it. Not this.
not that.
Okay, let's take another piece of paper. Doesn't matter. I have lots of pieces of paper in my pocket.
Okay.
Yeah.
So what we did was when we did the first fold, and we did this is the first fold. Let's say we picked this point.
Yeah.
Over here,
Yeah.
to do the second fold.
Uh-huh.
Then what we did was, so this was, let's put this up here. This is A, let's actually write it down. A, B, C, and D, right? This is the fold. It'll probably be hard to see on the camera.
Yeah. So there's a line here.
There's a line here,
Yeah.
there's a line here.
Yeah.
What we did when we folded it was that we put this angle below on top of this angle.
So they
So
made
they're
it in
congruent.
such a way they are congruent.
Yeah,
That's part of the procedure.
that's part of the procedure.
Yeah.
So since these are congruent,
Yeah.
therefore this is equal to this, and therefore by this definition,
Yeah.
these are both right angles.
Okay. So you are saying that angle ABC and angle ABD are congruent
Yeah.
by the construction, by the way we did it.
Yeah.
Therefore, they are right angles.
Yeah.
And then, of course, you're also assuming this is the straight line,
yeah.
and this is the straight line. If these two are straight lines,
And
then-
assuming this is also a straight line and that's also a straight
that's right.
Yeah.
Okay. Okay. So that's a mathematical proof.